Physics chapter 23 theory video 4 capacitors in series is what we are going to discuss about. So this is actually the opposite of what was happening in in relation to the resistors. So here we are dealing with more than two or more capacitors connected in series. Then the total C total of the capacitors are going to be calculated by 1 upon C total is equal to 1 upon C1 plus 1 upon C2. If there are more than 2, then it is 1 upon C total equals 1 upon C1 plus 1 upon C2 plus 1 upon C3, etc. Right? So this is how two capacitors are connected. Now once again you need to know how to derive at this formula, and that is once again another thing that they might question you upon. So here just like in parallel the same principles would apply. However, when they are connected in series, when the potential difference V is across them, this potential difference is going to be divided or shared between the two capacitors. So as a result, PD across C1 could be V1, and then the PD across C2 could be V2. The sum of them would be V. Then if we think about the charge stored by the combination of these capacitors, we can see that they would be storing the same charge. The reason is actually when a charge of negative Q would arrive at this point, what happens is the repulsion of the charge that would be leaving here. Now this would become plus Q, and as a result minus Q would leave from here and enter this place, that is reach negative C2, and that continues as it is. Let me explain if you did not understand. Let me explain this again. So now let's say a charge of negative Q reaches this point. Then what happens is this negative Q, C1, this plate will become negative Q charge. So as a result, you know that the two plates are equally charged. Negative Q means this will become positive Q charge. That also means negative Q charge is going to be negative Q charge which was here would leave, resulting in this becoming negative Q charged, and that would result in a positive Q charge here. So that is the reason why they become equally charged. I hope that makes sense. If you need further explanation, please let me know. So these are the capacitors. In the key equation is 1 upon C total. Remember that also, it is not C total equals 1 upon C1. It is 1 upon C total is equal to 1 upon C1 and C2, etc. What we need to understand is the total amount of charge in the system is constant. So this in here we are seeing an example for the conservation of charge. So now when there is this region, the region where the region between the capacitors, right? There is a significance in that as well. This part is initially uncharged, so at the end also it must remain uncharged, because the negative Q at one end will go to the other end. So what we need to understand is that part, right? That part simply allows the charge to go through without changing it. So as a result, the two capacitors are going to be equally charged. So that, in other words, what happens is the charge that arrives at this point reaches this point. So in this middle part is going to have no charge in the end. Uh, in this one, this allows us to write an equation V2 equals Q upon C1 and V2 equals Q upon C2 because it is the same thing, right? So then we get the combination of the capacitors store charge Q when there is a PD of V. So we get V equals Q upon C total. Then instead of V, we can write V plus 1, V plus V1 plus V2. That gives us Q, that is V. Now in the earlier situation we got Q upon C1 plus Q upon C2. So we substitute these values for V equals V1 plus V2. So as a result we get Q upon C total plus Q upon C1. Q upon C total equals Q upon C1 plus Q upon C2. So we can cancel out here. The plus sign is actually a mistake. These two plus signs should be equal signs. So 1 upon C total equals 1 upon C1 plus 1 upon C2 because Q to all the other Q's get cancelled out because they are common factors on either side. So let's look at this worked example. Calculate the total capacitance of 300 microfarad capacitor and a 600 microfarad capacitor connected in series. So we have 1 upon x or x minus 1 key. So what we do is we have an equation 1 upon C total equals 1 upon C1 plus 1 upon C2. Here the same mistake has been done. Instead of the equal sign, they have inserted plus sign. So 1 upon C total equals 1 upon 300 plus 1 upon 600. Then 1 upon C total is going to be 0.005 microfarad per microfarad, right? Now we get the reciprocal of this to find the C total. Then it becomes 1 upon 0.005, that is 200 farads. So that gives us the capacitance. Now this is 200 microfarads once again because it magically the micro part does not disappear. Here it is 200 microfarads. They have once again made a mistake of not including microfarad here. So the total capacitance of the two capacitors in series would be less than either of the individual capacitances. So that is another realization that you need to have. So earlier they had a capacitance of 300 and 600, but now it has a capacitance of 200 microfarads, right? So once again they have made a mistake. Like I said, here instead of microfarads they have included farads, so that is wrong. That's a printing mistake. So then you can use the x minus 1 key on the calculator and can do this calculation in one step. C total is equal to 300 to the power negative 1 plus 600 to the power minus 1 to the power minus 1 would give us 200 microfarads. If you feel that it is easy for you, you can choose that method. However, you should show these details if they ask for it. So I would suggest that you do question number 13 and 14. Before we move to comparing capacitors and resistors, let's write down a note on this. Capacitors in series. When capacitors are connected in series, the total capacitance is obtained as follows. Please draw this first. This is how you connect them in series. And after that write down 1 upon C total equals 1 upon C1 plus 1 upon C2. So obviously you understand that if there are more, it is 1 upon C3, etc. You have to add. This formula is reached by considering the following situation. Please draw this part of the circuit. When, leave a line and write, when the capacitors are connected in series, the voltage across both of them, if is V, it would be shared between the two as V1 and V2. However, both the capacitors would be charged the same because the charge that would arrive at, so please remember, this is, we are talking about the convention, okay? The charge that arrives at C1 releases a similar charge at the other end, which is going to reach C2. As a result, they are both equally charged. This combination can be written as V2 equals Q upon C1 or V2 equals Q upon C2. Hence, V, that is the total voltage, equals Q upon C total. When substituting these values to V equals V1 plus V2, we get Q upon C total equals Q upon C1 plus Q upon C2. Q upon C total equals Q upon C1 plus Q upon C2. So Q upon C1 is obtained here from this. Then Q upon C total was obtained here. This and this is what we are talking about. If you have any doubts, please ask. Then by cancelling common factors, we can reach the equation 1 upon C total equals 1 upon C1 plus 1 upon C2. Put a star and write down. When capacitors are connected in series, their total capacitance is less than either of the individual capacitances. So if you have reached something more, then you know that you have made a mistake. I hope you understood. Let's go to comparing capacitors and resistors in the next video. Before that, please do question number 13 and 14.